Alright, so here's the robot dog. Here's a quick demo of it standing and walking around a bit. Still needs a little bit of tweaking and stuff. We got to clean up those cables underneath. We actually have some wraps to clean those up. We haven't done that yet, so it needs more calibration and tweaking, I think. But it's supposed to move a little bit better. This is the LED light on the back. You can make it do a bunch. It can go through a bunch of different patterns and stuff. There's a little control. You can see the control here on the screen. For a brief moment anyway. This is it moving its head up and down. When you push it too far, it kind of stutters a bit, I think. But yeah, it's kind of neat that it can do that anyways. And here I am waving to it, and you can see me waving on the camera. So it basically streams. You can see whatever it sees. It also does like object detection and face detection. Here's it kind of struggling to walk. It's supposed to do a better job than this. Yeah, I'm not sure if it's the surface that's trying to walk on or if it just needs. I think there's some variables inside you can tweak. Anyways, moving along. So this is how we actually get it set up. So we download the Raspberry Pi imager. So we're starting with the software, getting the Raspberry Pi set up for the robot. So I already have the imager installed on my desktop here. Ridiculously easy to do. You don't even have to download Raspberry Pi OS. You can just click on the the version that you want here, and the imager will download it for you. And so I'm doing this voiceover for this video later. And here you just select the SD card you want to write it to. And that's the SD card that you're going to pop into your Raspberry Pi. And I believe I had some issues with this. I'm trying to remember if I actually did. But because I'm recording this after the fact, I'm not recording it while I'm actually doing this. So I just recorded myself doing this, and I'm just adding the audio later. But yeah, I believe I ran into some issues. I'm going to see if I'm going to see what comes up next in the video. I actually forget, it's been so long since I recorded this, but we're going to see. I think I ran into an issue, and we'll see what comes up. I think this is just me talking about Raspberry Pi OS. So yeah, here we go. I think it's because I ran into an issue, and I actually downloaded Raspberry Pi OS. I sped up those parts of the video too, but I believe this is me grabbing the image, selecting it, and then writing that. So rather than relying on so this tool is supposed to download the image for you and write it to the SD card, but it looks like what happened is it got stuck and had some issue, and I just couldn't get it to work. So I ended up downloading Raspberry Pi OS and then telling it to use the image that I downloaded. You're not really supposed to have to do that. So that wouldn't be normal. Normally you shouldn't have to do that, but the tool makes it so that normally the tool will do it for you. If you run into issues, just download it manually yourself. And then the next thing you want to do probably is set up Wi-Fi on your SD card. So rather than connecting to your Raspberry Pi some other way and then configuring Wi-Fi, if you know your password and your access point and stuff, you can configure it in this you can configure it in a configuration file on your SD card, and when Raspberry Pi OS boots, it's going to pick up that configuration file and use that to generate its own configs, which is pretty nice. Yeah, so here I am copying and pasting that file name, and then I'm going to paste over this configuration, and that should pretty much do it. Let's see here. Did I actually put the password in that file? Yeah, so I think I overwrote that password for the video. Yeah, so that's not my actual password. Anyways, yeah, so I think for the video I recorded it with that password, and then I put the real password in when I was done recording. Anyways, there are some other things you can add in here. Yeah, let's see, what are we? yes, we're gonna tell it to enable SSH, and so yeah, we'll just add a directory for that, and so when it sees that that exists, it's gonna enable SSH. So that's one more convenient thing to do. So yeah, we're going to take the SD card out and put it into the actual Raspberry Pi. Should be coming up in a bit. Or not, I might have actually skipped that part and just moved on to configuring the software. Yeah, so here we are. So I guess this is at the point we've already plugged in the Pi and booted it up, and supposedly it should connect to our wireless, and it looks like it did. So you can actually just SSH to pi@raspberrypi.local. And you know, assuming you don't have other Raspberry Pis in the network with the same name, that should let you SSH into your Raspberry Pi, so you don't actually have to figure out what its IP address is or anything. Just make sure you're on the same Wi-Fi network. And here we are. Here's the uptime, you know, showing some information about the system, the load, and all that, and you know, what OS it's running. So here we run this configuration tool. We do a few basic things. I believe I listed in the document guide that I wrote over here. Now, I'm going to be tweaking that guide and, you know, fixing it up as I go along. So it's kind of work in progress. But in any case, yeah, so like you could set up wireless there if you hadn't already. You can like you can configure the user, you know, set new passwords and things like that, which you probably should do for most any system. So I think that's about all I'm doing. Yeah, I think I was going to do something else here. Maybe interface options. Yeah, so we can enable VNC, which is actually going to be important. You might think that's just a convenience thing, but it's actually really important to have VNC to set this up. So the software that we're using, that we're installing to manage the robot, kind of requires VNC. So this is me getting VNC working right away. I actually downloaded the official version from Real VNC, rather than messing around with all the different versions that came with Ubuntu, and there are a ton of different VNC viewers and tools and stuff. Honestly, I wouldn't waste my time with any of them. At the very least, definitely the VNC viewer. Just get it from Real VNC. I had so much trouble with the other ones having like, I forget, I think they were mismatched protocols or something, but I ran into so many problems. It was crazy. But when I got the actual viewer from Real VNC, the company that like I believe they actually invented VNC. So that's like the source. That's like where it comes from originally. So you know, normally you'd try to get like open source stuff or things that are free or whatever. I mean, it is free to get the client from them, but anyways, normally I wouldn't, you know, I would just go for the open source version of a tool, but in this case I would say just get it from Real VNC, because they're the guys who actually made the tool in the first place. They basically invented the you know, the VNC protocol and came up with all the specs for it, so they're probably the right people to get the tool from, you know, if you want to make sure that it actually works. And yeah, so changing the wallpaper, because I always just like to do that, even though it's just on a robot and I'm not going to do real work on this desktop. And let's see, what else are we going to do? Alright, so there's our Wi-Fi. You could configure it using this tool. Like if you had connected with a keyboard and monitor, you could, before having enabled VNC and before connecting to the network at all, you could actually go in there and, you know, configure Wi-Fi through the GUI if you wanted, or you could do it on the command line, whatever you prefer. So Python libraries, that's the next step here. And if you need any of these commands, check the link in the description. Yeah, I should have a link to this document in the description of this video. So this guide that tells you how to set it up, I should have all of that. But we start out just doing a git clone of their repo. So yeah, that's the Git repo from Freenove, the company that basically put this robot dog kit together. So you just pull it down from their GitHub repo. And I probably should have cut out more of this video. Alright, so here we are checking the version of Python. We have Python 2.7.16, which I believe we want Python 3 actually. Alright, so here I'm removing Python and linking Python to Python 3, and yeah, so there we go. Now when we type Python, it's going to run Python 3 instead. So there we go, Python 3.7.3 on our Raspberry Pi. Now, I believe I also later on ended up installing Python 3 on my desktop also. And here you can also get to the configuration using this this graphical interface. And notice we have SSH and VNC enabled already. We're going to enable the camera and I2C. And this is an interesting parameter. I actually wanted to go back and see if I configured this properly. So it says set I2C baud rate, and setting this baud rate will actually affect how quickly your robot moves. If you don't set it, if you don't change this, your robot will move pretty slow. But if you do change this variable, it should allow your robot to basically, ultimately, it's going to result in your robot moving faster and actually. Yeah, basically, I believe I might have done this wrong. I'm gonna have to go back and check, or maybe my configs were wiped out or something, but I'm gonna have to go back and check. But that's the purpose of this anyways. Yeah, so launching setup.py. So this is going to, yeah, supposedly this needs to be run from VNC and not from the command line, or you could run into issues. And here I am just changing the color scheme, totally unnecessary, but it's the kind of thing I do. Yeah, so we're using the LX terminal from the LXDE project. It's just poking around and looking at things while this continues to run. I probably should have sped up this part of the video. Yeah, nothing too exciting here, just some VNC info. Yeah, I definitely should have skipped this and just cut this out of the video, or sped this part of the video up. But there we go, we're just about done. So from here I'm going to reboot, and you can see VNC disconnected. Now it's time to get into actually building the robot. So this I've sped up like 4 times. This is 4 times the actual speed. So yeah, obviously my hands don't move that fast. So yeah, quadruple the speed. Yep, these are these are basically all the parts I'm taking out of the box now. Nothing too exciting yet. So these are all the motors. There's a lot of motors that come with this. And there we go. There's a close-up of one of the motors and some of the the extra parts that come along with it. Yeah, make sure you use the right parts. Don't just grab a part because it came with the motor and it looks like the right type of screw. So that was one of my first mistakes, is I used the wrong type of screw. So definitely pay attention to the instructions when it tells you to use a particular type of screw. Make sure you do use the exact type of screw and don't assume. Look at the actual number on the little bag. But I'll point it out. There's also a big warning sign in the video saying, hey, this is wrong, don't do this. Fortunately, they gave me one more part for the leg than what I needed. So the screw that I tried to install, it didn't fit very well, and it ended up breaking, and it would have been a huge pain. But I ended up having extra parts, so things went well. It was a learning experience, but it wasn't it didn't end up being too huge of a problem. It just kind of wasted some of my time, that's all. Alright, so throwing all the parts and screws and stuff in a bowl. Way better than just leaving them laying out on your desk. And notice that notice that these parts, the distance between the screws will be different depending on which side of that wheel you're measuring. So do pay attention to that and do orient them correctly. Now these are all the parts. They are not made of particle board. I believe these are acrylic, so they are pretty nice, and they do look about as nice as. So in my original unboxing video, I had said, oh, this looks like particle board or something, because I didn't get that. You know, until you start peeling it off, you don't really realize the material that's, or I didn't realize the material it was made of. But once you peel this, you know, the sticky cardboard stuff off of it, like you get all that paper peeled off, you'll see it's some pretty nice shiny acrylic in it. It's pretty decent. It's kind of the quality you would expect from seeing the video. All right, and here we are. You notice that big red warning that says wrong. So I'm about to do something that's wrong. So don't do this. I'm going to do it the wrong way, and shortly after it shows, after that warning message goes away, I'll show you the correct way. So notice I have 5 of those leg pieces. You only really need 4 of them. So fortunately I didn't damage this. But I was taking the screws that came with those wheels, because the wheels will eventually have to connect to these legs. So I was like, oh yeah, those must be the right screws. You know, I just made a big assumption, and that was wrong. So, oh yeah, and here's me showing my iFixit toolkit, which was all fine. You know, it was a terrific toolkit, but yeah. Anyways. Here I am pointing out the correct screws to use. So yeah, for every step, just look at the guide. If nothing else, like either use my guide or use the official documentation from their website. Whichever one, just follow the guide and use the correct screws. And here is, yeah, that's a close-up of the broken screws. So yeah, just pay attention and use the right screws. And that's all you have to do to avoid this issue. So here I'm going to screw the correct screws into each of these pieces. And there we go. Nothing too exciting, just, you know, screwing in some screws. Alright, so here we go, that's almost all of them. One more to go. And there we go. There is, you know, there's all the leg parts. You know, there's a close-up. So yeah, that's all fine and great. Put those aside and let's start looking at these next. So we're going to install these you know, these disc or wheel parts on these other components. Alright, so just screwing some more screws in, nothing too exciting. Yep, just screwing in another disc. Yep, just peel some more of this paper off of these parts. Alright, so this part was a little bit tricky, but once you get a little bit of practice, it's not too hard to do. You basically just have to hold the nut right in the exact spot. You kind of have to put your finger there so it doesn't fall through, and then stick the screw in, or the bolt in rather. And once the bolt is holding it in place and pushed in a little bit, you can kind of just screw it in, and it'll thread right in. It works. It's not as hard as you would think. Like, you'll see it and be like, no way, there's no way I'm gonna fit that in there, but it works okay. Yeah, and that was, I just showed my the tweezers I was using. I had this iFixit tweezer kit three different types of tweezers. Anyways, yeah, and showing the type of types of bolts and nuts and stuff that I'm using to put this together. Similar to what I just did before. You know, putting the nut inside that little hole and then sticking the bolt through, and yeah, I mean basically what you see in the video. Yeah, so that's basically how that fits together. Yep, and here these, yeah, more bolts and some copper standoffs. Yeah, and here I am, just sticking the SD card in there. I'm not sure why I put that clip there. Yeah, and here we are, putting the robot board on, putting standoffs on top of the robot board. Yeah, that SD card clip, that very brief clip a little bit ago, that didn't belong there. That was supposed to be in another part of the video. It's too late now. Definitely not going back and rearranging everything now, especially after having, you know, 34 minutes of audio recorded already. But there we go. Got, M3 nuts and bolt and screws. I guess they're calling them screws. They look like bolts. Anyways, that's the type we're going to be using to connect this, to connect the LEDs. And with, as with everything else, basically just you can see what I'm doing there. Then we can connect this top portion of the chassis that contain the LEDs, so we can stick that on top and connect this cable to it and use that to connect it to the robot board. And notice we're putting tape here. That's because we have some more bolts that we're going to be sticking in those slots, and it's going to be, we basically stick nuts in those slots, and then we're going to be, we need them to stay in place while we then stick the bolts in, because they won't actually stay there until the bolt is in place also. So they just fall through really easily, and it's just way easier having tape there. And there's the actual Raspberry Pi 4 and the screws we're going to be using. So we're going to connect it to the standoffs here Here I am using that tiny screwdriver that came with the kit. Alright, so just putting these nuts and bolts on these motors here, you know, connecting the leg parts to the motors. Basically just exactly what you see. Tweezers can come in handy to get those nuts lined up just right. It was trickier than I thought it would be. You know, how hard could it be to put a nut on a bolt, right? But when it's in a tight spot like that, you know, especially with how close the side of it is to that motor, it can get a little tricky to get it on straight. Then I found I could like kind of hold it with my finger there once it's actually in place. And you'll get the hang of it after you do a whole bunch of them. Yep, and so there we go. We just have some, you know, more motors and leg parts to put together. So yeah, just more of the same basically.
All right, so here we are. We're just putting together these other leg segments. These are further up on the leg. So we're going to put a few of these together, basically exactly what you see here. Some of them will be facing one direction, some face the other direction. Basically just copy the, what it shows in the instructions. And yeah, that's pretty much it. Or you could pretty much just copy what you see me doing here. So just putting a bunch of these together, and that's about it. All right, so yeah, here we are. We're working on the chassis, pulling off a little sticker there. Remember to take that off. Had a little bit. Oh yeah, and here we are. We're connecting these. We're connecting the cables to this now. And I believe this first time, yeah. So this first time that we connect the cables, you're supposed to connect them in a random order. Like it doesn't matter at all what order you connect them in. This is just going to do the initial. You know, we run the servo program to bend the joints at a certain degree. We run that program once after we have all these plugged in. And after having done that, later on, we're going to unplug every single one of these and plug them into very specific spots. And each one has to go in the right spot, obviously. That way the robot knows like which leg it's moving. And, you know, so obviously they have to be plugged in the right way. But for the first time you plug it in, like what I'm doing here, you just plug them in randomly. Definitely don't take the time to plug each one into the right socket. Just plug them all in just so long as each one is powered. And like they specifically say to do this in the manual. So just plug them in, and then we're going to run the servo program in a little bit. Zoomed out view of everything. Yeah, there's all that stuff plugged in there. Oh, and these are the batteries. So I bought these on eBay. Yeah, so we only need 2 of them. The other 2 are going to go into our robot car. But yeah, these 2 go in here, and surprisingly the batteries burn out pretty quickly. You got to recharge it after not too long. I haven't measured how long it lasts. But yeah, and so here we go, turning the thing over. Yeah, so yeah, there's some of my joints and stuff. I think I'm just messing around with how yeah, so we're getting the thing plugged in now. And yeah, so looks like you plug it into the yeah, so you definitely plug it into the robot board, not the Raspberry Pi itself. Yeah, so I think that's me motioning to the camera, hey, don't plug it in the Raspberry Pi, plug it in the robot board. Is that, you know, I can't tell. Did I plug that in the wrong port? Yeah, so anyways, okay, so I got it. So there was an example of me plugging in the correct port, then the wrong port, now back to the correct port. And oh yeah, I think the one thing I was pointing out is that you want to, oh, and here we go, I'm connecting in some more things. And also worth noting, use the cable that comes with it, plug it into something with enough power, but worth noting, I tried using my MacBook Pro charger, and that did not work out. I had some trouble with that. Yeah, you know, thinking back, watching this video, I noticed that one cable was white. The white cable is from my MacBook Pro, and that did not work out. So yeah, I'm using this black cable. I believe it's the one that came with the robot dog. Plugging it into the robot board. That way we power it on by pushing the buttons on the robot board. So yeah, and I think I turned the lights off there so you could see the LEDs a little bit better. Yeah, see on the right side. Oh, and yeah, I cut away from it. Okay, so we're launching VNC here. You know, just log in. Same thing as that we did before. Am I typing my password wrong? All right. Anyways, coming up. Yeah, you type it into VNC, and then you type it in to log into your display manager on Linux. So basically, you log in twice. No big deal. Yeah, cancel out of this. So from within here, we're going to run the servo program. That initially sets up the servos. And from what I can tell, it just bends them at the right angle. So there I am, pasting that command in there. Just run, you know, sudo python servo.py from within the code server directory for the robot dog. And let's see, what do we do? Okay, so at this point, we are going to connect these joints So we do this after having run the servo program. So the servo program rotates the motor to a certain known angle, and once it knows where that is, that's kind of like a reference point as far as I understand. And at this point you try to install, you connect the different leg joints, the different leg segments, and you have to connect them, get as close as you can to 90 degree. Like, it's going to be off a little bit. It's going to be either tilted one way or the other. That I found is hard to get away from. It's not going to be perfect, but get it as close as you can, just because every time you move by like one of the teeth in the gears, it's going to be off by like a few degrees. So no big deal, get as close as you can. And yeah, that's pretty much it. Yeah, just sticking some more joints together here. All right, now connect these to this upper motor assembly thing. Remember, we built a few of these before, and pay attention to which direction they face. But yeah, so they're basically like the third leg segment. I wouldn't call it a leg segment. I don't know, joint or whatever, but it's a little motor housing to move the entire leg. And I kind of did as good of a job as I could to line this up. There's only so much you can do. It is frustrating not being able to put it in one exact spot and have everything be perfect. But yeah, I mean, do the best you can. It ends up fine. It works okay. As always, make sure you're using the recommended screws. And here we go, actually attaching the legs to the robot itself. So they'll attach, I think, a little bit differently in the front versus the back, but you'll see. So yeah, I'm getting these back legs on first. So you basically have to push that thing on in place, and then you have to actually put your screw through this hole here. It's a little tricky, but it's doable. It wasn't too bad. Alright, so now we're going to put this front faceplate thing on. And yeah, make sure you grab these correct M3 nuts. It's amazing. I turned the lights off so that you could see it better because I thought there was too much glare. Looks like actually watching the video there wasn't too much glare. It was just the screen on my camcorder that made it look like the glare was too much. And this is where, yeah, you have to put these bolts through just right, and then or the nuts through just right, and then you can stick the bolt through and it lines up, and once it's in there, it's good. I believe that is where that's what you wanted the tape for before. The tape helps it so that it doesn't fall through, so it's easier to hold it in place when you're sticking the bolt through. Do the same thing from below here, because we have two of them. This is where the piece of tape we put on there before comes in handy. And there you go. Now the other side. So this part has a little, I guess you could call that like a neck joint thing. Here I am showing the screws again with the lighting changed. Turns out to not be necessary at all. Good to know for future videos. Alright, so we're going to connect this little neck joint thing to this front plate. This is the same. Before we installed like a back plate thing over the legs, and now we're putting this front plate thing on the front. We're putting that little neck joint thing that the head is actually going to connect to, I believe. Let's see how that fits. So in this case, we just connect the legs directly to this front panel. Yeah, they're the nuts and bolts again. Here we go, put this whole assembly, push the whole thing on here. Add some more bolts. Oh, and there's another example of the tape coming in real handy. That was really helpful to have there. If you can fit that nut right in this is a great angle to view it from, even though I'm not zoomed in. If you can fit the nut right into the right spot, then when you put the bolt through, it'll go right into the nut and pull the nut right into place. Everything fits nice, secure, nice and snug and secure. Works out pretty well. Do that on both sides. Tighten everything up. And then, oh, here's the screws for the next part. All right, so here is another component. This is the camera. This is the Raspberry Pi camera, basically regular Raspberry Pi camera. Fits into this faceplate here. So we're basically assembling the head right here. Yeah, we're gonna put this little connector on here. So the camera's gonna go on, and these ultrasonic sensors are gonna go on. They look more like eyes. So we're gonna use these little screws to connect this to the plate here. And this part of the robot just looks really neat. This is just probably one of my favorite parts. Similar thing with the ultrasonic sensor, screwed in place. Basically just exactly what you see me doing here. Alright, so we gotta carefully connect these little pieces here. And as with everything else, just make sure you do it right. Use the right screws, you know, have it facing the right way, etc, etc. There wasn't too much to this, but yeah, basically exactly what you see I'm doing. Once you get more than one screw in, it's obviously not gonna move. Yep, and here we go, just connect this together like so. Got that nice side piece connected to the head now. Things are starting to come together and look nice. Also gonna get that front plate connected on there. And now we're gonna have to worry about this blue motor. Yeah, it's like the one motor that's differently colored than all the others. It's a different model, but this one is for the head. It basically makes the head go up and down, like you saw in the demo video at the beginning. And here we go. Not too difficult at all. Just screw the motor right on in. And I mean, after putting this thing together, I actually kind of felt like the head wasn't supported as well as it could be. It could use a little bit more, could use a little bit more to hold it up, but I guess there's only so much you can do when, it has to be free moving and, it's all based on that one little gear connected to that tiny motor. So, I mean, I guess that's like the nature of it, right? But yeah. Zooming out. Let's see, are we about ready? No, not quite yet. Few more things to do before we get. Yeah, actually this is the part where I connect the head. Alright, yeah, it's been a while since I actually did this and I'm just doing the voiceover. So I can basically watch what I did, but I forget the steps off the top of my head. And there we go. And put this thing on the other side, but on the other side this doesn't actually connect to the neck. It doesn't connect the head to the neck. So you could almost think of the left side of the head as being like, just for looks or whatever. It's like cosmetic, but I mean, it would look wrong without it. I mean, like a lot of it, like a lot of the shapes and stuff. It's just, because you want it to look that way.
Alright, so yeah, disconnect all of these. Like I said before, we were going to disconnect these. It didn't matter the order, because before this thing ever even gets up and moving, we're going to disconnect every single cable here. And we are then going to have to put them in the correct order, which takes a bit more time. You'll see I'm doing it relatively quickly, but it actually took me a while. This video, at least this part of the video, is moving at 4 times the actual speed. That's why my hands are moving super fast and everything. I just sped up the video by 4. And here we go. And as I'm doing this, I'm like reading off the reference. I wouldn't recommend trying to do this without actually looking at the manual. Yeah, just make sure you get them in the right spots. But yeah, I wouldn't try to do this solely based off of watching this video and like eyeing things up based on the video and trying to figure out, oh yeah, this wire comes from this motor and goes to these pins. No, that's gonna be, I mean, maybe you could tell by this video, but I mean that's kind of a big mess of cables there, so you probably want to just make sure you match it up really carefully based on the documentation. I mean, I did end up doing everything correctly here. Like I mean, I got the thing up and running. So if you are able to duplicate exactly what I'm doing here, then great. Here you're probably gonna have it up and running. It's just probably more effort than it would be to just look at the manual. So like maybe you want to watch what I'm doing just to get an idea of what it's like, but then do use the manual for reference. It's gonna help you. And here we're going to connect up the we're going to connect the camera. So yeah, plug one end of the cable into the camera, and I believe I put a note in here either for the ultrasonic sensor or the camera that you have to plug it in right, or you could actually burn out the device. So I forget which one offhand, but if you look at the documentation I wrote and at the official manual, it's going to give you a little warning at this part saying plug it in the right way. So yeah, definitely make sure you plug it in the right way. Don't reverse how it's plugged in, or you could end up destroying something. Like you don't want to have like power input coming into something that's supposed to be a signal, right? Like if you have something that's supposed to be like 5 volts of power or however much power coming into something that's not supposed to be providing power, but something that's just supposed to receive a signal, you could burn out some circuitry. All right, this is the camera cable on the this is how we connect the camera cable to the to the Raspberry Pi itself. I think that camera before might have been that thing before was the ultrasonic. Yeah, that cable before went to the ultrasonic sensor, or did it? That's yeah. Anyways, yeah, this cable that I'm plugging in here goes into the camera for sure. I mean, that's definitely the spot on the Raspberry Pi where you put where you plug the camera cable in, and this is where you plug it in here too. Yeah, but I would make sure both of the so if you got a better look here, I was wrong. That's not the before we did the ultrasonic sensor cable, and those are those multicolored cables, and now this ribbon cable is the camera cable for sure. I mean, we can see very clearly here it's getting plugged into the camera, and we saw it getting plugged into the camera port on the Raspberry Pi. So yeah, I mean, I've connected the camera more than enough times on the Raspberry Pi. That's definitely where the camera cable goes and how it looks. So it's pretty much just like connecting a regular Raspberry Pi camera to a Raspberry Pi, except that it's part of a robot. And these are, so we're pretty close to being done. These are the these are the stands that you're going to use when you calibrate it. So you basically, and then this is kind of a pain. It'd be nice if you could just attach and detach these a little bit more easily, just in case you have to recalibrate it or whatever. But
yeah, you actually have to screw these in. These are stands that are gonna like kind of suspend the robot in the air so it can freely move its feet without actually walking or anything. So it's gonna like, you'll see in the demo when we run the program to calibrate it, it's gonna like stick its legs out in the air and move them around and stuff. So you do have to have it standing on these stands. And here we go. All right, so here I powered on, and notice as soon as I power it on from the robot board, even before powering on the Raspberry Pi, its legs just sort of moved right into position, and it does that right away as soon as you power it on. And here we're gonna try, yep, there we go. We can SSH to the Raspberry Pi, and really I'm just checking to see if it's up. I guess I could have pinged it or something just as well. But yeah, I'm just SSHing into it to make sure I have a connection right here. And let's see, I should be opening VNC pretty soon. So you'll notice I have like I have another video screen up in the upper right hand corner, and yeah, I'm just sitting here not doing anything. I probably should have shortened this part of the video, but yeah, so that thing up in the upper right hand corner of the screen. All right, there we go. That's me there. I just turned both the robot board and the Raspberry Pi on. All right, so logging into VNC now, finally. And we're gonna see as I run the programs, as I run the setup and testing programs, you'll see you'll see my screen here as I run the commands, and you'll also see the little video window up in the upper right hand corner of the actual robot moving around and being configured for some of the steps anyways, the ones where it moves its legs and lights up. And then the others, some of them you're just testing out internal components. There's just nothing to really see. But yeah, well, that's coming up right now, so we'll see that. First thing to run, you won't really see anything. This is just this just gives us some information basically. Yeah, so just doing I2C detect, and those are the values we're going to expect. You see the screenshot in my documentation here. Just make sure when you run it, it basically, matches up to that. All right, so this next command, this should actually make it move. Nothing too crazy or exciting, but it is going to move. You'll see as I run the command, the robot moves. All right, test.while, there we go. See the legs going up, stretching out, and then they move forward. And there, the program's complete, and it's staying there in that position for now. So yeah, test.py and tell it to test the servos. So it's just running the test on the servos. Actually, to be correct, we're basically just testing everything. We're not actually, this isn't a configuration phase, this is just testing. We will be calibrating it later on, just getting like the legs lined up exactly and everything. So I think that's why you wouldn't worry so much about, you wouldn't worry as much about what happened, you're lining the legs and the joints up exactly when we were connecting them before, just so long as they're within a certain range. So here we test the battery. We can see the voltage when we do a few tests on it. All right, hit Control C to finish the test, because it doesn't hit a natural end of the program, it just keeps running. So let's see here, next thing we run here, we're gonna test the LEDs, so it's gonna change them to different colors, and it'll print out on the screen what it's changing them to, which is pretty neat. Oh, sorry. This one is the ultrasonic sensor. It's telling us the distance to whatever is in front of it. Let's see, the lead should be... Here we go. Here's the lead test. Oh, there we go. Red, green, blue, white, and done. Yeah, I actually, the resolution was so high I actually can't, oh, there we go, running the test again. Yeah, I actually can't read the text over in the document on the right side on this video, because the video was, my screen I recorded was in a really high resolution, and I didn't zoom in on the text, and I have this video, while I'm editing it, doing the voiceover, I have the video shrinked down really small, so I can only read what's in the terminal and not what's in the actual document. So yeah, some more tests. So we tested the buzzer, testing video. We're just making sure the device is there. It's just something so we can have a definitive test of the video. And let's see, what are we gonna do here? All right, and each time we don't have to CD to the directory over and over again. All right, so this is gonna take a still image, and then we're gonna verify that. So from the command line, you can tell the camera to take a still image, and this is the same. You could do that with a regular Raspberry Pi. It's just not, that's not unique to our robot. That's a regular Raspberry Pi thing. But we told it to take the picture into this directory, which is fine. There we go, image, and this is the image it took. Has that little, has like this PC and some other junk on my desk at the time. And this stupid, you know, this owl statue light thing. So yeah, that's what the robot was seeing. So here we go, we can run the main program. And this is one reason to be on, some of these programs won't work if you don't do it in VNC because it just expects it. This one actually has a GUI. So to start the remote control server on the robot, you need to launch it using a GUI, which you might think is a nice thing, but it's actually not. I mean, you have this on-off button. Realistically, anytime the robot is powered on, you probably want the server to be running. Why wouldn't you? Honestly, I'd prefer this to not be a graphical program. I'd prefer this to be a CLI program and just run as a daemon in the background, but what are you gonna do? I mean, I was considering maybe modifying it myself to make it run that way, but we'll see. That would be like a future thing if that ever happens. So yeah, we've started up the server, and now we are going to launch the client. So stopping that part of the, did I stop that part of the video? All right, so I'm actually setting the client up for Linux. Yeah, so yeah, basically, you have some commands for you can run it on Windows, Mac OS, Android, iOS. You get an app for Android and iOS, and Mac OS and Linux. You just download their program from GitHub and run it. But for Linux, they should make Linux more of a first-class citizen, seeing as how the robot actually runs on Linux. But for the client, they gave you instructions to run it from Linux on a Raspberry Pi, but not from a regular Linux desktop. But what I'm doing here is I'm running from a regular Linux desktop. So I am getting this, if you just follow along with what I'm running here, I am getting this thing running on a Linux desktop. Oh yeah, and I went through a few steps here. So you could follow along with what I'm doing, but basically I had a few issues. But it took me a few shots to actually get this working. Yeah, so ultimately, you know, I had to do, I'm gonna quick just run through, you can watch what I'm doing here, but I'm gonna just quick list off what I did. in order, but not in sync with what you see what's happening in the video. So you could follow along with the video or just listen to me quick list off what I did. I'm going to list off what I did, but you could also copy what I did in the video and get the results you want. And I believe I have this updated in the document. If not, I'll try to get it updated. All right, so first thing I did apt install a few libraries like you see in the instructions there under Run Linux Client on a Raspberry Pi. The reason this is different is because I'm running on a regular Linux desktop and not on a Raspberry Pi. So I'm running it on my Ubuntu 20.04 desktop installation. So anyways, first thing I did was apt install a few libraries. Then I did pip install a few libraries, but it failed. And so I checked the Python version. I did apt install Python 3 pip because I only had Python 2 pip, and I retried doing the pip install for a few libraries, failed again. And then because there was a version conflict, so I then I tried without the version being specified, and that gave me a much newer version of the package, which turns out to be completely fine. So they were telling you to specify an exact version of the package, which is old anyways. So if you're running a modern Ubuntu, you may as well just install whatever the latest is. It worked for me anyways. So then tried without the version and it worked. And then we did an apt install for more libraries, couldn't locate them, did an apt update, still can't locate. Then I actually had to add a repo, and then I did an apt update, and then I ran the apt install libraries again, and it worked. And that's what I basically did to get the client actually set up. So that's the process I went through. All the the pitfalls and everything that I went through. That's what I did. So yeah. Anyways, yeah. Paste this command over here, and let's go. Let's see, what did I do wrong here? Python 3, yeah. Make sure, so instead of saying Python, like they'll tell you in the documentation, just say Python 3 explicitly. And that is and there we go. The robot powered off. I think we ran out of battery power, so VNC disconnected. That's a big tip off that it just shut down on us. But on our regular desktop, we were able to at least get the client working. So this is us with the client up and running. And all right, so I cut away and I came back after charging it. So I believe this is the point where the Raspberry Pi has been, in the robot, basically the batteries for it have been recharged and it's ready to go again. So trying to SSH in, this is just a way for me to tell that it's up and ready to take connections. I guess I could just ping it, but this is what I'm doing in the video, and it works completely fine. No issue with this at all, I guess. I mean, it proves that the system is all up and running and ready for connections. So here we run VNC again, using the official VNC client from Real VNC. And there we go, there's our login screen. Log in again. You've probably seen me do this a few times already in this video, but continuing on ahead. So yeah, see how before we can actually even do anything, even though we have a working client, we still have to launch this server on the robot using VNC. Bit of a pain, but what are you gonna do? So launch the server with a GUI and then click on to turn it on. I mean, it's nice they went through the extra effort to create a GUI for that, but it actually just makes things more difficult. I guess it theoretically is supposed to make it more convenient, but it doesn't. Especially when it requires VNC. And this is me, all right, there we go. That's me launching my client on my Linux desktop. And it's not too different if you run it from Windows or Mac OS. I have the instructions there on my website that you see on the right side, so you can follow my instructions, or you could look at the official documentation, whichever way. All right, so here I am.
So I connected to it successfully. And here's me just poking around, and you hit the calibration button, brings up this other calibration screen where it has like an XYZ box to visit for each of the 4 legs. So you can actually position the legs however you like. Now I probably should have shown the video of the robot being calibrated. I may or may not have actually recorded it while I was playing around with this, but I don't have that video overlaid over my screen right now. But basically, as you hit X and Y on this thing, X, Y, and Z, you can move the legs back and forth and up and down and stuff. So yeah, that's how you do that. Yeah, so this part isn't super exciting, but this is basically what it looks like when you try to adjust you basically set the robot on the stand on a piece of paper and try to adjust the legs so they're all touching down to the ground at just the right spot so they're all lined up correctly before you tell the robot to start walking around and stuff. So it looks like I finished up the calibration. Not that they don't move all that fast anyways, so that's not super exciting, just something you have to do. And here I am making it walk forward and backward and stuff. We're actually going to show the Android client as well. I think I have the Android client, and I forget if I didn't record the iOS client, but I connected it to it from both, you know, Android and iOS. All right, so what am I doing here? Looks like I opened up the color screen. Yeah, I mean, it's basically what you see is what you get. That's all the stuff you can do with it. Let's see, why am I opening a terminal? I'm not. All right, let's see here. So playing around with the colors and stuff. Oh, and there we go. There's the video stream. So this is the room that I'm in. You can see like all the fun looking posters and stuff on the wall and all the toys and whatever else in the room. So yeah, this is the video stream coming from the robot. We can make its head go up and down, look up at the ceiling. See, am I gonna have this thing actually walk around? Yeah, we're having the robot walk around. It's lagging a little bit at the moment, and we had some issues with the robot actually moving quickly. I think we needed to tweak some things.
As you saw at the beginning of the video with the demo we had. It's a tiny bit of work. There's a video stream again. Oh, there we go. There's the red ball. So this is kind of a little more interesting. It tracks the red ball. I don't know if you can see on the screen. Is that showing up well in the video? But basically, it tracks. It's putting a little circle around the red ball, like it's able to track it using AI, basically machine learning. And is this the face? Yeah, this is the face ID. So you could scan a face, put a name on it, and then it will try to recognize that face later on. See, am I gonna put my face in the picture? Oh, there we go. Here's me putting my face in the video. So you see that it draws a circle around my face, and it can detect my face pretty easily. And let's see here. There I am again. There's my face. Let's see, was I gonna have it detect me, or did I have to actually launch that program? So I wish I had done a better face recognition demo. All right, so here's the robot. I'm gonna demo it walking and stuff. So yeah, here it's trying to move. It looks like it can't get a good grip because of the material this table is made of. It looks like it just cannot grip it, so it's not moving. Also, legs just aren't quite bent right. I'm not sure how far off that is. I think I just didn't calibrate it well, and I need them to be bent forward a little bit more, kind of. So it's not quite bent the way it needs to be. Look, here it's trying to like strafe left and right. It's not doing a good job. It's doing a better job at that than it did of moving backward and forward. So for one, it moves a little bit slower than it should. I think there's a variable we need to tweak in the system to get it to move better. I'm gonna have to look into what's going on with that. But the other thing is, it definitely looks like it has a bad grip on this surface. So that's kind of a problem, but you see it is actually turning. It's totally capable of coordinating its legs and turning sideways. See, its legs are kind of splayed out more than it should be. Look at the head going up and down. That's pretty cool looking, right? So yeah, the movement at the moment is a little disappointing, and you see I still have to neaten up the cables and stuff, and hopefully we can get it fixed up so that it moves a little bit better, try it on a better surface maybe, and maybe just, you know, and hopefully some tweaking just makes it move faster. But otherwise, there we go, it's going into sleep mode where it just sits down. So if you move it for a certain amount of time, eventually it's gonna get down on like basically its knees and take a rest. You can still do other stuff with it, like move the head and take pictures, turn on the LEDs. See, I'm turning the LEDs on there and they're changing colors and stuff. That's pretty cool. Yeah, that's actually, you'd think LEDs are just some silly thing that who cares about, but those do look pretty neat. Obviously not the most neat or complicated thing about the whole robot, but still. Anyways, so what else? Yeah, not much else happening right at the second. It's just gonna do something in a bit. There we go. The lights are changing a little bit more. Yeah, get a good view of the robot close up, and also of the 3D printer in the background. It's changing to yellow. All right, I guess that's not too exciting. Oh, head's going up and down. And what else? What else is he gonna do? We got a few more minutes of this clip, and we are going to switch to the other clip. Notice how it stutters if you push it all the way to the limit, like the furthest it can go down, it'll start kind of stopping and it won't be able to go. Anyways, just interesting to note. Here we have it trying to turn a little bit more. It does look pretty cool, and there it just pops right up. It does look pretty cool with especially with all, you know, those neat looking, I guess, you know, ultrasonic sensor eyes in the camera, and like it does look neat if only it, you know, moved a little bit more swiftly, which I think we can probably fix, but I have not done that yet. So for this video, this is about as smooth as its movement is going to be. It doesn't get too, I think actually the next clip it might move a little bit better, but a little bit slower. I think I had it fixed up a bit in the next clip, but even still, it's far from ideal. But it is still, it's moving, the thing's moving, all these joints and stuff. It's amazing it works at all with all the different parts and stuff and all the different joints and what you have to do to calibrate it. It's amazing it does anything. Here's me messing around with it. I think I'm like changing the tilt or something. Eventually it's gonna like kind of fall over and be, you know, out for the count or whatever. Let's see. It is pretty neat. Look, you get it to shift from side to side, lean forward and stuff. So that is kind of really cool. And boom, I don't know if he's getting up from that. So yeah, he's kind of, yeah. I don't know that I can fault the robot for that. That's the operator's fault. Well, partly he's not as slick as he needs to be, but also, yeah, this is pretty bad actually. I may not be operating the robot the way he should be, but I'm really not. Yeah, it should be easier to keep him from doing this. he's pretty much, he's out for now. This was recorded a good while back, maybe like at least a month ago. And this next clip I recorded only like a week or two ago. And this is him starting. Notice his legs are much straighter, and I've gotten the angles worked out a bit. This is more like how he's meant to move. This is like more, and see, it looks like he has a better grip. It doesn't look like he's slipping that much. He might be a little bit. Be nice if he had like rubber tips on the ends of his legs or something. But and look, you can bring the speed up there, but that doesn't seem to help too much.
bringing the speed up in the client. The client just does not seem responsive enough, but it works. I'm able to get him to move around. Yeah, he's still not moving as fast, so I guess I got like the, you know, the angle of his legs and all that stuff worked out, but I need to, I still need to get him to move faster and a little bit more swiftly. So maybe a better surface to move on. Still, the wood seems to be helping rather than that plastic table he was on before. And beyond that, I mean, yeah, I think it's a combination of the two things: the surface he's moving on, and just the speed. He needs to be configured to just move his motors a bit faster. And no matter what he does, he burns through the battery pretty quick. The battery just goes. Before you know it, like, you get the thing on, by the time you actually get logged in, get VNC started, you know, get the server started, get the client running, make sure you're on the right network, actually connect, and then actually start trying to get the thing moving properly, you've already burnt a good chunk of battery already. You only have so much time, and you can only move around so much, and you're trying to figure out like what you're doing wrong or whatever. Before you know it, the battery's going to be out. And all right, so here we are, just a quick close-up. I cut a lot of this out in my demo video, and there we go. We see the lights moving around in that neat pattern. That's pretty cool. Let's see, what else do we have here? Oh, look at that. They're flashing pretty, that's some pretty crazy flashing we got going there. And let's see, what else is up? Now it's doing like a breathing pattern. I guess they call it breathing, but that's also kind of neat. You know, if you wanted to change and be dynamic, but still be a little subtle. Yeah, and this is the interface that we change the colors in. Yeah, this clip is actually what I used to put together my demo clip that I for my demo video that I published not too long ago. So yeah, not too much else to say about this. We're just, you know, you can see in the reflection in the screen, the colors are still changing. Yeah, there's me waving my hand, and you can see my hand on the screen in the video stream. So yeah, everything's mostly working as it should. And yeah, what else am I gonna do here? I didn't do a whole lot in this clip, but it's still a pretty good clip for demoing the robot. Alright, so hopefully you enjoyed this full video. Hopefully someone finds it useful and helps them put their robot together. Maybe it helps you decide whether or not you want to buy this robot. Anyways, you know, any questions, comments, criticisms, leave a comment down below. Give me a thumbs up. Remember, you know, hit that like button. You know, subscribe if you want to see more excellent content like this. You want to see our next robot, our next programming project, our next server we configure, whatever else we're going to do, 3D printing, networking, electronics, whatever. We're doing a ton of stuff, coding and all sorts of interesting things. You want to see that kind of content, hit the subscribe button. And you're going to want to hit the little bell icon so you get a little alert when we come up with when we put out our next video, because we do have a lot of great stuff planned for the future, and you're not going to want to miss it. So as always, hopefully you enjoyed the video, and we'll see you next time.